Hello, my little chickadees. For those of you that don't know me, I'm Miss Brauer, and for those of you who do, hey, good to see you. I'm going to do a presentation on the pH scale. Hopefully this will all go according to plan and you'll actually be able to get through this video with me. I am hopefully projecting my screen. Part 4 is on the pH scale. The objective of this is to compare and contrast pH values in terms of hydronium ion concentration. We will realize that there is a hydronium ion concentration and a hydroxide concentration in different solutions, but we're going to look at the hydronium ion for the pH. Now, some of this information is more than what you need, but I think you need to kind of understand what's going on in order to easily tell us what we want you to know. So here's the first big deal. What is the pH? It's a mathematical scale of the concentration of hydronium ion, and we're going to use the numbers of 0 through 14. So what it says here is it's the opposite of the exponent of the hydronium ion molarity. Well, let's skip right down here. If this is the molarity, that seems like a pretty small number because it is, so we put it into an exponent form to the negative 11th. Those two numbers, this one here in the decimal and this one here, are the same thing. All we have to do to show pH scale is say, oh, it's a pH of 11. Because in actuality, nobody wants to say 1 times 10 to the negative 11th molarity. They just want to say it's a pH of 11. So all they've done is taken this number, given it a positive value, and made that the pH number. So contrarily to that is if we have a pH of 4, then that means the exponent would be a 4 with a negative sign in front of it, and we would have 0.0001 molarity. It's that simple. pH is relating hydronium ion to hydroxide ion, and we're going to use a scale of 0 to 14. 14 is going to be the magic number, because if I take a pH of 3, that is 10 to the negative 3 that we just looked at in the last slide. Well, if I take 14 and subtract the 3, I get negative 11. Or if I should say, if I take the difference between them, the 14 minus 3 gives me an 11, but I put that negative sign back in front of it. What happens is that tells me the hydroxide ion concentration. So out of the 14, part of that number is going to represent hydronium and part of it's going to represent hydroxide. So if I have a pH of 3, hydronium, the H3O plus, is going to be 10 to the negative 3. And if I have a hydroxide, which is the OH, I just take 14, subtract 3 from it. That gives me 11, and that gives me the the hydroxide ion concentration of 10 to the negative 11. If I do it conversely of I know the hydroxide concentration, well, if that's to the negative 1, then 14 minus 1 would give me a 13. So that's the hydronium ion concentration, and that's actually what the pH scale is hydronium ion concentration. So if hydronium ion concentration is 10 to the negative 3, I have if hydronium ion concentration is 10 to the negative 13, then I have a pH of 13. To visualize it, when I look at a solution to determine acid-base concentration as far as hydronium versus hydroxide ion concentration, both of them will be present. So it's showing me if it's more acidic, there's going to be more hydronium or H+. If it's basic, it's going to be more hydroxide concentration. When I look at a neutral solution, that means for every hydronium ion, I have a hydroxide ion. And if 14 is our magic number, then half of them have to be hydronium ions and half of them have to be hydroxide ions. And 14 divided by 2 is 7. So therefore, pH of 7 means I have 10 to the negative 7th molarity of hydronium ion concentration, but it would also mean I have 10 to the negative 7th molarity of hydroxide ion concentration. those two numbers would be the same because they would neutralize each other or balance each other out. This is one of the things we're going to want you to know. Hey, if we're talking hydronium and it has a 10 to the negative fifth molarity, just know that you take that number for 5 and that's the pH of 5. This 10 to the negative 12th molarity becomes a pH of 12. 10 to the negative 2 molarity becomes a pH of 2. All it is the positive value of the exponent becomes the pH value. It's that easy. Now, if I say, hey, this is what the hydroxide ion concentration is, what is the pH? Remember, pH is about hydronium ion concentration. So I have to do a little math here. If I have the hydroxide ion concentration, remember, 14 is the magic number. Subtract 4 from it for the hydronium ion. 14 minus 4 is 10. That gives me a pH of 10 for the hydronium ion concentration. If I have a hydroxide concentration of negative 11, 14 minus 11 gives me a pH of 3. If I have a hydroxide concentration to the negative 8th, 14 minus 8 gives me a pH of 6. It's as easy as you take 14 minus the exponent of the hydroxide, the OH minus value, and that's going to give me the pH. Also, in interpreting the scale, anything less than 7 is going to be acidic. If it is exactly 7, it is neutral. If it's greater than 7, it's basic or alkaline. Now, another concept we want you to understand is decreasing and increasing pH values. If we decrease it, meaning we go down a number, we're making it 10 times more acidic. That is something that we're going to multiply together, and we're going to look at that in a slide in a minute. If we increase the pH, then we're increasing it by 10 times. It's the whole 10 times or 10 power of 10 thing that we have to worry about. So, something that we want you to know. If we change from a pH of 2 to a pH of 3, that's a 10 times difference. And going from 2 to 3, we're getting closer to 7, so that makes it 10 times less acidic. So a pH of 3 is 10 times less acidic than a pH of 2. Another way you could look at it is a pH of 3 is getting closer to 7, so it's going to become more basic. So it's still a power of 10 because we've only gone from 2 to 3, but you could say that it's 10 times more basic. So 10 times less acidic, 10 times more basic are basically the same thing, just depending on if you're talking about if it's more basic, more acidic, less acidic. If we look at numbers that are further apart, so let's say we're going to change from a pH of 11, which is basic, to a pH of 5, which is acidic, well, I go from 11 to 10 to 9 to 8 to 7 to 6 to 5. If I count on my fingers every time I change, so 11 to 10 to 9 to 8 to 7 to 6 to 5, I'm holding up 6 fingers right now. Notice that 6 fingers represents 1, 2, 3, 4, 5, 6. Because you're taking 10 times 10 times 10 times 10 times 10 times 10. So there's a 1 millionth difference or 1 millionth power difference between a pH of 11 and a pH of 5. So I always tell my students, when you're doing these questions, I'm expecting to see them while they're taking the test or a quiz to actually be counting on their fingers. 11, 10, 9, 8, 7, 6, 5. I'm going to add 6 zeros because that's a difference of 1 million times as far as one pH number to the next. One thing that we can do to make it a little bit more different is notice that these are whole numbers. If I made them decimals, okay, as long as the decimal behind them is the same number, it's the same thing. Just pretend like the decimals aren't there. And I'm going instead of from a 2.6 to a 3.6, it's just like I'm going from a 2 to 3, just like on the last side. If I'm going from 11.2 to a 5.2, it's the same thing that I did on the last slide as far as 11 to a 2. So again, I'd forget about the decimal. I'd go 5, 6, 7, 8, 9, 10, 11. 6 times differences, that's going to be 6 zeros in my answer. I've already know how much more acidic or basic one is compared to the other. So we'll expect you to do whole number values and those values that have decimals of the same value. One difference is, what if the decimal isn't the same value? What if I go from a 2.6 to a 3.7? Can't do that. Now we can on a logarithmic scale, but we're not going to use logarithm. So if I give you something like this, you can't do it. If I give you an 11 to a 5.2, since this is 11.0 and that's a 0.2 there, we can't do that. So we're just not going to do that. Now, that concludes this video. I would recommend that you talk to your teachers if you have questions. I would recommend that you ask questions of your teachers. You look over this a couple times, see if you have any questions, and do all that before you answer any questions on the form. Thanks for listening, and I will talk to you later. Bye-bye.